All right. Let's start with learning and then the machine learning. Okay. So let's understand what is learning. Okay, learning has multiple levels actually. Suppose you wanted to recognize as a pattern of a pattern of an object or a pattern of an image. We call it as a pattern recognition. Okay, not just image. You can even recognize a pattern of numbers. That's one way of learning. And the another way of learning is kind of reasoning. Okay, we apply some reasoning before we take some actions. Okay, if you drive a car, okay, you kind of reason before you apply a brake, you accelerate, you change the gear. Okay, and that is how we take. We kind of drive the car. Okay, so it can be very trivial like pattern recognition, or it can be very reasoning based upon the situation we have. Okay, so machine learning can be divided into broadly two categories, and one is this kind of pattern way of learning. Another one is reasoning actually. So we'll start with the pattern learning first. Okay, and then we will go in detail about reasoning later. Okay. Um, so how do we start the pattern recognition? Okay, so when we are a kid, okay, let's assume that we don't know anything about this world. Okay, and we first see this object. We don't know what it is. Okay, and our mom or dad, okay, labels this as apple and informs us, okay, this is a fruit called apple. Okay, and what we do is immediately we kind of observe this object, okay, or a fruit, and memorize it. Okay, memorize the pattern. We don't memorize the entire pixels, and we just memorize the pattern of it, and we store it in our memory. Okay, and call this as an apple. And next time, okay, when we happen to see another apple, okay, we immediately recollect from our memory that, okay, this should be called as an apple. We though both these apples are not identical in shape, okay, and the texture is also a little different. Okay, one is having pure red here, and there is some mix of yellow and red here. So we don't that doesn't bother us actually. We still call it as an apple. Okay, so what we as a human we are good at is we are able to abstract the information what we observe, and retain only the necessary stuff which we need to recognize things. Actually, that is how we kind of live. Okay, we don't memorize pixels of any objects to kind of tell what it is. Okay, and if that is the case, what will happen is if you zoom in your photo, okay, let's say 500%, and just show the teeth or to your mom, you she may not be able to tell that it is you, because that's not the she may not be recognizing you at the pixel level. Okay, what she recognizes is the structure of your face, the position of the eyes, and just the basic features. That's enough for a mom, or for even for us as a human to recognize anybody. We don't just try to retain all the information what we see. Okay, that's the abstraction. Okay, and that's how we learn. If you look into another example of how we learn, okay, we'll start from an example like a multiplication table which we might have studied in our school. Okay, 1 into 2 is equal to 2. 2 into 2 is equal to 4. Okay, 3 into 2 is equal to 6. Now, a teacher teaches us this pattern. Okay, 1 into 2 is equal to 2, 2 into 2 is equal to 4, 3 into 2 is equal to 6, and asks you the question 4 into 2 is equal to what? Okay. Now, as a grade 1 or 2 student, okay, they may not be able to answer it immediately. Okay, they might have to, they would have memorized it like, okay, this pattern exactly as it is. 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is equal to 6, and they might not be able to actually say it follows a pattern and we need to call it as 8. Okay, I mean, they will do it in a while, but immediately as we start learning, they might not be able to tell that it is 8, because learning starts with memorization, and only if you memorize it to a reasonable extent, you'll be able to find the pattern. Just because you memorize doesn't mean that you have learned. Okay, if you are able to tell, okay, 5 into 2 is equal to 10 without even having the teacher to tell you what the answer is, then which means that you have learned it. Okay, if you do not know what 5 into 2 is and you just know only up to 4 into 2 is equal to 8, what it means that you have memorized it. Okay, that's the difference between memorization and learning. Though memory is an integral part of learning, memorizing doesn't mean that you have learned actually. So this is how we learned. Simple multiplication table in our schools. Okay. Now, in a traditional programming, what we ask is, this is an input, okay, and I multiply it some number, and I get this output. So let's say the programming just similar to pseudocode. Okay, you start like initializing x is equal to 1, and you find y is equal to x into 2, and you print y. What this is going to do is it is going to take input as 1, multiply it by 2, and print y, that is output of 2. If you run this in a loop with an incremental of 1, okay, then next it's going to print 2, 4, 6, 8, 10. This is a traditional program actually. So it is deterministic, which means that there is nothing complicated here. You are given an input and you know what to multiply with, and you are expected to get the output. So if you give this program the value of 6, it is just going to tell you 6 into 2 is equal to 12. Okay, this is what the traditional program is. You get the input, you get the function, we write the functions, we know these functions beforehand, we write it, and then we ask to get the output. So what we get in our programming is traditional programming is the output. Okay, given these two input and functions, we get the output. Now in case of machine learning, what we know is, we know 1, we know the output of 1 is 2, we know 2, the output of 2 is 4, we know 3, the output of 3 is 6, we know 4, the output of 4 is 10. So this is the input and this is the output. Okay, we get the input, we get the output. Now we wanted to find out the function by which we need to multiply to get this desired output. Okay, now the challenge is, you and if you are known I mean, like this multiplication table beforehand, if the machine knows this beforehand, it would guess that it is 2. Okay, but the machine does not know this actually, unless you kind of have a rules where you can pick it and then tell, okay, this is what it is. Then you can give the rules to kind of use a number 2 to multiply it. But we want the machine to learn, so we need to have a process by which the machine tries to find out this number. Okay, but when I say this number, it is basically this function. It is trying to find the function y, which is by what number if I multiply 1 I will get 2, with what number if I multiply 2 I will get 4. So this is basically a function f of x. Okay, and f of x is can be written as y is equal to x into 2. Okay, so we are trying to find out find out this function. So now how do you go about it? Okay, and how does the machine go about it? So the best way for the machine to kind of try to figure out what the function is to start guessing. Okay, let's say we initialize it with the number 1. Okay, and we get an output 1 into 2 is equal to 1, and 2 into 1 is equal to um, 2. Now if you see, we guessed 1, okay, and we get answers. Okay, 1 into 2, 1 into 1 is 1, 2 into 1 is 2. Now what we see is this, we know the expected output. Okay, we know this is the actual this is the predicted output by guessing 1. Okay, now what happens is there is a difference between these two that we call it as an error. Okay, let's say we call it as an error. The difference between 2 minus 1 is 1, 4 minus 2 is 2. Okay, similarly if I guess 1, 6 minus the answer would have been 3, 6 minus 3 is 3. Now if you see that there is an error which is kind of increasing. Okay, and we can figure out, okay, probably 1 is not the best guess because the error seems to be large and it is increasing. Let's say we have next guess to kind of, let's say we make it 1.5 instead of 1. Now what we see is here is like 1 into 1.5 becomes I just this 1 into 1.5 becomes 1.5, 2 into 1.5 becomes 3, 3 into 1.5 becomes 4.5 something. Okay, so what happens is, now if you see the error between 2 and 1.5, now the error is reduced to 0.5. 4 minus 3 is 1. Okay, so you see that there is a decrease in error between 1 and 2. I mean, like initially we got error 1, now we get error 0.5. Initially we got error 2, now we get error 1. So if you multiply by 1.5, error is reducing actually. Now this gives you an intuition. Okay, we might try to probably increment a little bit further. Okay, let's say we multiply it by 1.75. What we see is 1 into 1.75. Now this becomes 1.75. The error becomes 0.25. Okay, and this becomes 2 into 1.75, this becomes 3.5, and error becomes 0.5. So now if we see that as we started with the initial guess of 1, and we incrementally are increasing this numbers by point 0.5, then 0.25. Okay, so what we see is that there is a decrease in error from 1 to 0.5 to 0.25. So similarly, second example, we decrease error from 2 to 1 to zero point 0.5. So we have found out a process by which we start with a random guess, okay, and we kind of go in a direction which reduces the error. We will be able to get answers closer to what we wanted to. So now let's say the next guess becomes 2, okay, next guess becomes 2. Now the 1 into 2 becomes 1 into 2 becomes 2, and 2 into 2 becomes 4, and 3 into 2 becomes 6. Now if you find the difference between the expected output and the predicted output, you will see that it is 2 minus 2 is 0. Okay, from now what happens is we have reduced the error from 1 to zero point 0.5 to 0.52 is 0. So similarly, the second example also 0. You can stop there. So if you have a process by which you can incrementally start with a random guess, okay, and then try to find what is the best number that we should be getting multiply with to get the desired output by kind of looking at the output and the error and try to reduce the error. Then we have a systematic way of marching closer towards the actual output. So machine has learned this number 2 by using the input and the output and trying to start with a random guess and slowly reducing the error, and we find out this function which we initially started with. So if you are a deterministic programming, if you're disrupted, I mean, like you're expected to give, I mean, get the output given the input and the function, you immediately write this. Now we have reversed the process. We have asked the machine to use the input and the output and try to find the number 2. So this is what is called as machine learning actually. Okay, this is how the machine learns. This is an example of even though it is a very simple example, this gives an intuition of the entire process of learning.